This video will provide a very quick overview of collaboration of experts achieving 80% top 1 accuracy on ImageNet with 100 million flops, which is a way of measuring the amount of computation in these neural networks. So overall, this is a new approach to ensemble learning and organizing the training of an ensemble of experts organized with some kind of delegator network. So this is the COE, Collaboration of Experts framework. You have a delegator model, which maybe you just exit with an early prediction if you have enough confidence, or you select from the ensemble to get a better prediction from the ensemble. So here's the key idea with how we're going to train this expert assignment and how we're going to train this delegator to pick among these candidate models in an ensemble learning framework. So we have a weight generation module and a label generation module, and they're solved with transportation algorithms like optimal transport and this idea like the Sinkhorn-Knopp algorithm that's used in the SWAV contrastive learning algorithm to make sure you have a balanced assignment of codebook clusters in this kind of contrastive learning framework. And now we're looking to make it have a balanced selection of the experts throughout the training of the overall framework as we're training the experts alongside the delegator in this framework of not, say, having the experts train on different subsets of data. So in models like divide and contrast, you would train each expert model in the ensemble on its own little subset of the data, so it's the expert of this subset of data, compared to having some kind of delegator that parametrically selects which expert and kind of guides the training that way, compared to just explicitly chunking the data like in this divide and contrast kind of style. So it's an interesting approach for training this kind of model and how exactly you're flowing the gradients through into the different experts and controlling it with this delegator model. So here's a high-level overview. I'm sorry it's not super detailed, but here is the results. Very interesting performance gains, because you wouldn't imagine that an improvement of MobileNet would come from an ensemble learning strategy. You'd think that it would come from some, say, projection, low rank, or some depth-wise separable convolution, these kind of more efficient layers, some idea like that, compared to the idea of an ensemble achieving state-of-the-art in efficiency, which is surprising.